All right, boys and girls, this is huge. This is a huge lesson today. Some huge understandings that we're about to take part in. Before we start, I just want to get into a word here that you may have heard before, and that's algebra. Now, algebra is pretty much just math using what are called variables. Okay? It's using operations like addition, subtraction, multiplication, division, using numbers, and it's also using what are called variables, which are symbols that are used to represent a number. Now, the variables that we're going to use are going to be lowercase letters. Okay? So variables could be really any symbol, but we're going to use letters to represent variables. So I'm going to show you an example of how or why we might use a variable in an example here, and then we're going to work with variables and expressions today to sort of get started with this idea of algebra, of using symbols to represent numbers. So right here it says you have a box of markers. Perfect, there's the box, very plain box. 2 markers are outside the box. Write an expression that represents the total number of markers you have. Well, if you were to never open this box, you know you have 2 markers, but you don't know necessarily how many you have in here. That's when a variable might come in handy. If there is a number that we don't know, we might use a variable to represent that number. So, in order to write this expression, I need a variable. So what I'm going to do is I'm going to write what's called a let statement. It's called defining the variable. I'm going to explain what the variable is and what it means. So I'm going to say let, I don't know, I can pick really any letter. I'm going to let y equal the number of markers, so you can see that, in the box. Because again, I don't know how many markers are in that box. It could be any number. So because I don't know the number, I'm going to use the letter y to represent how many markers are in the box. So I'm actually just going to write the letter y right on top of the box. Y is how many markers there are in the box. We know we have 2 markers outside the box. So I'm going to write an expression that represents the total number of markers. To do that, I need the variable y, which is the number in the box, plus I know I have 2 markers outside the box. This expression right here represents all of the markers I have in the box, outside the box. So this is an expression called an algebraic expression. We used a variable to represent a number we didn't know, and there was a number we did know, that was the 2 outside the box, and we combined them, we added them together to find the total. Now sometimes you don't know. You will never find out how many markers are in the box, but sometimes you do. So for example, it says, suppose there are 14 markers in the box. Find the total number of markers. So we're going to use this expression to help us find the total. So show your work. I'm going to start with the expression we had, y plus 2. That was the number of markers we had, plus an extra 2 outside. Now it says there are 14 markers in the box. So instead of y, we now know that there were 14 in the box, plus 2 outside. 14 plus 2, 16 markers. Should be equal signs here. Whoop. So notice, we first didn't know how many there were. We wrote an expression using a variable. Then we found out how many there were. We added them together to find there were 16 total markers. So it says, explain your answer. There are 14 markers in the box and 2 outside. That is 16 total markers. Whoop. So that's what this expression means. Markers inside, the markers outside. We first use a variable because we didn't know how many markers. Pardon me, I had to sneeze. We didn't know how many markers were inside. We needed a variable to describe it, and then we found out how many markers were inside. We found the total. So this is when you'd use a variable. Use a variable when you don't know necessarily the value that you're working with or the amount that you're working with. Now, this is going to be a big change here for some of us, because when we use algebra, the x that we normally use for multiplication is now a variable. So we cannot use the x, because really any number can be a variable. Like in this expression, n plus 2. N could be a variable. Any letter A through Z, really, except for there's a couple that we might avoid, like the letter O because it looks a lot like a 0, or the letter L because it looks a lot like a 1 if it's not cursive. But the letter x we can also use as a variable. So we don't use the multiplication symbol x anymore. We can't use that when we work with variables because the x looks too much like a variable. So instead, there are 3 different ways that we can show multiplication. The one we're going to use the most, probably, well, there's 2 that we're going to use the most. One is the dot, right? So when you see a dot, that means multiplication. This means 5 times the variable x. And again, we don't know what x stands for at this point. There's also parentheses. When you have a number right next to the parentheses, this almost means like 5 groups of x, because when I think of parentheses, I think of groups. 5 groups of x. We don't know what x stands for, but it's not going to be the multiplication symbol anymore. So we can use parentheses, we can use the dot. Another way to use it is if you have a variable, you can just put the number right next to the variable. That also shows multiplication. But these 2 are the ones we're going to use the most often. You might see this one as well. So what we're going to do is we're going to practice finding these products now using these different multiplication symbols. So what this means is 5 times 6. When you see the dot, it's multiplication. Well, 5 times 6 is 30. I like to think of this as like 8 groups of 4, or 8 times 4, and 8 groups of 4 is 32. Again, this is just when you have a number right next to parentheses, that means multiplication. 4 times 10, well, that's 40. Now with this one here, you'd actually have to use order of operations and do parentheses first. And we can do 4 plus 3 would be 7. So we end up with 6 times 7, or 6 groups of 7, which is 42. Now, if you were to try this one, 3 squared, you'd have to do that first because it's an exponent. 3 squared is 3 times 3, which is 9. So this winds up being 4 times 9. Notice we're using the dot here, not the x for multiplication. 4 times 9 is 36. Now the last one, I'm not sure why it says just the value here, but there it is. Oh, find the value it's supposed to be. I guess it was cut off. We can't find the value of this because we don't know what the x is. If we knew that the x was, let's say, 10, we can do 5 times 10 to get 50. Well, what if the x was 8? Then it would be 5 times 8, which is 40. But what if the x was 1? 5 times 1 is 5. So because we don't know what that x stands for or what number it's supposed to represent, that's all we can do with this expression. We can just leave it as 5x. There's nothing else we can do. Or 5 times x, you'd say. So again, there are a couple different ways now that we're going to see multiplication. The dot, the parentheses, and when a variable is right next to a number. So we're going to have to keep our eye out for that. And when we write an expression, we have to make sure not to use the multiplication x anymore. We're going to use the dot or the parentheses, or just putting the number right next to the variable. So we're going to see some examples of that right now. So we're going to be on page 15. 15. So what we're going to do is called evaluate an expression. These are one-step expressions. So let's try some here. Now, you know me a little bit, and my first step typically is to rewrite the problem. It's no different here. We're going to rewrite the expression, and then we're going to evaluate it. So it says evaluate 16 plus b. So the first thing I'm going to do is write 16 plus b. Now, if we didn't know what b was, this is as much as we can do. But we do know what b is. B is 25. So in my next row, after writing the expression, I'm going to write 16 plus 25. Now, of course, if you couldn't do that in your head, you can always do it off to the side. Whoop. And that's going to be 41. So again, the first step, write the expression with the variable, substitute the variable for the value, and then you would, do the math. You do the math from there. Now this one's interesting because there's two variables. This is a minus sign, just so it's on a dot. This would be x minus y. So we're going to write that first. Do we know what x is? Yes, x is 64. Minus y, which is 9. Now, if we didn't know one of those, we couldn't solve the problem completely. We couldn't evaluate it because we wouldn't know what the answer would be. We didn't know what the value would be. So 64 minus 9, we do it off to the side, of course. 14 minus 9 is 5. 5 minus 0 is 5. So we get 55. 55. Okay, now this one looks a little unusual. G, this is a division problem. G divided by 4. When it's a fraction, that's like division. G divided by 4. G is 36, so 36 divided by 4. Now we'd have to write this as, I guess, a mixed number, you can call it, or this is just going to be a whole number because 4 goes into 36 9 times. Nice. Nice. Okie dokie. Let's try this next row here. 6x if x equals 6. Now you say that as 6x, but really what this is 6 times x. So if you want to write it with a dot, you can do that as well. Like if you don't feel comfortable with that, if you want to rewrite it with a dot, you certainly can. The key thing is here, you don't want to write, because we know x is 7, you don't want to just write 6, 7, because that's 67. It's not 67, it's 6 times 7. So in my next step, I'm going to write 6 times 7. Well, 6 times 7, I believe we did that earlier, 42. Just going to turn the light back on. There we go. Okay. This next one here, we got another two variable one, x plus y. Two variables. X is 4 plus y is 8. 4 plus 8 is 12. Okay. Last one here. Okay, this one's interesting because it's just two variables next to each other. That means r times w. When a variable is next to a number or another variable, it means multiplication. So what I'm going to do is actually rewrite this as r times w using the dot. All right, let's see. R is 12. So it's going to be 12 times w is a 1/3. Let's do it. All right. I'm going to change 12 into a fraction too. And then we'll just, well, actually, before we multiply, we can actually simplify it because we're multiplying. We can simplify this diagonally. 1 times 1 you can't do anything with. 12 and 3, you can divide them both by 3. 12 divided by 3 is 4. 3 divided by 3 is 1. 4 times 1 is 4. 1 times 1 is 1. And 4 divided by 1 is 4. So again, you just do one step at a time. You don't want to do too much at once because that's when the confusion starts to set in a little bit. All right, so some big takeaways. One, you always want to write the expression first. If there's a variable in there, you want to write it first. Then you want to substitute in the numbers you have. Then you would just solve it as normal. All right, now these at the bottom, I'll give you, if you want to, you can try these on your own. You can do them with me. But the letters for all three of them are up here for the variables. A, whenever you see A in any of these problems, A is 12. Whenever you see B in any of these problems, B is 4. Whenever you see C in any one of these, C is 3 2/10. Okay? So let's try this one. If you want to try these on your own, again, you can. But make sure you write the expression first. A plus 8 is our expression. Do we know what A is? Yes, we do. A is 12. So instead of A, we're going to put 12. And 12 plus 8, believe it or not, is 20. That one wasn't too bad. All right, this is A minus B. A minus B. Got two variables for this one. Well, what's A? A is 12. What's B? Well, B is 4. 12 minus 4 is 8. Oh, yeah. Feeling good about this. A divided by 2. Remember, when it's written as a fraction, that's division. So A divided by 2, that's an A, not a 9. Do we know what A is? Luckily, we do know it. Oh, I put 12. Luckily, we do know what A is. A, maybe I was thinking about 12. A is 12. So instead of A, we're going to put 12 divided by 2. Well, 12 divided by 2, 6. So far, so good. So far, so good. All right, these next three are all multiplication. We see here, there's a dot here. A times B. A times B. Well, A is 12. We know A is 12. Times B, we know B is 4. 12 times 4, 48. 48. All right, 9C. Well, what that means is 9 times C. When the number is right next to the variable, it means multiplication. So I'm actually, when I rewrite this, I'm going to write it as 9.C. I can rewrite it like that. Not a problem. Not a problem. You'd need the dot in there anyway. You couldn't just write 9. C is 3.3 2/10. So you just couldn't write the 3 2/10 right next to the 9 and call it a day. You actually have to multiply it. Now, actually, you know what? Because there's a decimal here, I'm actually use parentheses for multiplication. Because the dot kind of looks like the decimal point, so I'm going to do parentheses there. 9 times 3 2/10. A lot of times when you have a decimal in there, you want to use the parentheses just so it doesn't look like you don't confuse the dot with the decimal point dot. All right, 9 times 3 2/10. Might have to do that one off to the side, which is okay. So this is going to be 28 8/10. A little bit more than 27, which is what we expect, because 9 times 3 is 27, and then just a little bit more would be 28 8/10. Last one, this is my personal favorite. We got BC. That means B times C. When the variables are next to each other, that's multiplication. But I'm going to rewrite it as multiplication with a dot. No, you know what? I'm going to use parentheses because there's going to be a decimal in there, because C is a decimal. That's another way to write this. You could write it, I guess, as B.C, but I'm going to use parentheses here because I know I have a decimal. All right, B is 4. C is 3.2. So all we have to do is multiply those. Let's do that right here. Should be a, yep, that one's pretty easy. 12 8/10, which makes sense because 4 times 3 is 12, and then a little bit more would be those 8/10. So if you try those on your own, hopefully those went well. If you did them with me, that's fine too. What we're going to be doing, and hopefully these ones were not too bad for you. Hopefully you've followed all the steps. We want to make sure to follow steps each time, because starting tomorrow, we're going to be working with two-step. So you're not doing this page right now. We're going to be working with multi-step expressions, something like that. Like this one's a little tricky, so I wanted to start out, and there's one. That one's kind of tricky too. We're going to start out pretty simple, and then tomorrow we're going to kick it up a notch, take it to the next level. But I hope this made sense. Start working with the variables. We'll start doing some algebra. All right, boys and girls. If you have any questions, let me know. If not, have a marvelous day. I'll see you soon. Bye-bye.